right, so let's start with A. What shape is letter A? It is a cylinder. It's got two circles. Cylinder. Letter B, is it a prism or a pyramid? Prism. And what shape is the base of this prism? Triangle. So triangle, prism, B. C, prism or pyramid? Pyramid. What kind? Rectangular. Pyramid, C. D? Yeah. A cube is a type of prism, but meh, it's a cube. Letter E? Rectangular prism. Letter F? It's right here. It is also a rectangular prism. So a cube is the three-dimensional square. So all the sides are squares. But a rectangular prism, the sides are rectangles. All right, we're at G. Prism or pyramid? It is a prism. It has two bases. And it is triangular. So G. And then H, prism or pyramid? Oops, I wrote this in the wrong place. G was a prism, and H, correct, is a triangular pyramid. It comes to a top vertice. You can use a scientific calculator if you have one. If you don't, I would just take out a regular one. It's not a big deal. We're just multiplying a lot today. You need a highlighter as well. So we're talking about volume. The next four sections are all about volume. If you had to tell a second grader what volume was, what would you say? Not the weight. The amount that can fit in something. That's exactly it. So we are specifically talking about prisms and about cylinders. Okay? So I'm going to tell you the formula right here, right now. You ready? And you're going to say it back to me. Volume equals area of the base times the height. That's it. So the reason we have an area quiz on Friday is you have to find the area of a bunch of shapes today. You literally, a three-dimensional shape. Let me get 2 sheets of paper. I'm going to take over your desk for a minute. Everyone sees that these are the same sheet of paper, right? What shape are they? They're rectangle. They're two-dimensional, which means there's a length and a width, but there's no depth to it. I'm going to need you to use a little bit of imagination. Can you hold up your hands? You can hold one of them. You ready? So to make something three-dimensional, there are two bases. These are 2 sheets of paper, and they're congruent, right? In order to make a prism three-dimensional, okay, they are separated. They're congruent. This would be a rectangular prism if you envision. So all you do is you find the area of the base and you multiply it times whatever the height is. And that's a prism. Okay? So we are going to practice that a lot. A prism, we've talked about it. What kind of prism is this? Rectangular. What kind of prism is that? Triangular. What kind of prism is that? It's also triangular. Okay? So what you would do is you would identify the base, find the area of the base, and then multiply it times the height on each and every one of these. Even though they're different shapes, it is the same process. Okay, so here's what I want you to write down. You are first going to write down this. It's not very helpful as it reads, not unless you know the letters, obviously, and what they mean. So there's a box towards the bottom of the paper. It says volume of a prism, where V is the volume. This is what it will look like on your reference sheet. If you were to take the public schools FSA, this is the geometry reference sheet. It does have this volume formula. It does not tell you that it is for a prism, but it is written just like this. Volume equals, and it's a capital B and a lowercase h. What I write down throughout the class, the capital B represents the area of the base. So go ahead and write that in. The capital B represents the area of the base. Good. Okay, that's good. And then the H stands for the height, and it needs to be of the prism. So go ahead and fill in that it is of the prism, which is important. Okay, I'll tell you a little bit about each of these. How many bases are there for a prism? 2 bases. They are congruent and parallel. So let's take a look at some prisms. What kind of prism is this? It's triangular. It's got 2 bases. Everyone see it? There's 1 base, and then I can't take off the other one. But there's another base. Okay, what about this one? What kind of prism is this? I'll be slow. It is a hexagon prism. Okay? Okay? And then the height of the prism, you want to write this down. The height of the prism is what pushes the bases apart. The height of the prism is what pushes the bases apart. The height of the prism is what pushes the bases apart. So when you think of height, as you should, you think of height as up and down, right? A vertical. But sometimes they're going to give you the picture sideways. So the height of the prism is the height it pushes the bases apart. So we said this is a hexagonal prism, correct? If it were sitting sideways like this, like if it were like this, everyone would know the height is here, right? Because that makes sense. But the reason that this is the height is because this is the distance from the 2 congruent bases. If it were turned on the side, the height would still be the same. The height is what pushes the bases apart, even if the height isn't up and down. Okay? We'll practice it a lot. That's why you have a highlighter. It's really easy to see in a picture when you highlight the 2 bases, because what's unhighlighted will be the height. Okay? Finding the volume of a prism. Stay on this page. We have not turned yet. Just finding the volume. I want you to first highlight when we get to it. It just makes it so much easier to see where that height is. Remember that there are only 2 congruent and parallel bases. So if you highlighted more or less, you did not highlight the 2 bases. You're then going to find the area, because we need the area of the base. You find the area, you plug it in, then you multiply it times the height. You will answer in cubic units. Okay, so inches cubed, meters cubed, and here's why. When we answered in perimeter, let's just go back to the beginning. If we had a rectangle, how do you find the perimeter of any shape? Perimeter? Add all the sides. So let's say that all of these sides were in inches. The perimeter would be blah, blah, inches, correct? If we went for area, how would we answer for area? We do length times width, and we'd get blah, blah, and then inches squared, because that's how many squares can fit inside of the shape. Everyone get it? Sorry that they're ugly. So when we answer in volume, it's 3-dimensional, right? So I don't care how many 2-dimensional squares you can fit. What I do care about is how many cubes you can fit. And everyone knows what a cube looks like. What's the most famous cube that there is? The most famous cube?
A TV.
Okay, I guess there's an ice cube. A Rubik's Cube is what I was thinking of, but whatever, it's fine. It's figuring out how many cubes you could fit inside of a shape, okay? Here's what you are going to write down. Make sure you're staying with me. I feel like you're not. The area of, you want to write this down. I'm just reminding you all the area formulas you need to know. To find the area of a rectangle and a square, what is the formula for a rectangle? Length times width. And then for a square, I already told you, but you can use length times width. But what is the official formula to find the area of a square? Side squared, correct. So tomorrow you're going to learn when I give you the volume and you're going to find a length, you need to have the official formula or you won't be able to find the length. It'll be much harder. Okay, the next one, a triangle. What is the area formula for a triangle? 1/2 base times height. You're also going to draw some triangles because we're going to talk about it. We're going to talk about this. Draw a non-right triangle as well as a right triangle. So draw 2 triangles. Your quiz, the formula quiz, you're going to have to tell me the formula, but you're also going to have to write in where to use the formula. So this is 1/2 base times height. If this were your quiz, I would be asking you to put the base wherever the base is and the height wherever the height is. So here's what that would look like. What do we know about the base? What will the base always look like? Side to side. We call that horizontal. It's good. It's always the horizontal side. Sorry, my handwriting's terrible. So the bottom of my first triangle would be the base, and the bottom of my second triangle would be the base. And the height is always measured vertically. Right? Always measured vertically. So looking at my first triangle, is this side a vertical side? No. Is this side a vertical side? No. When you measure height, it's from the very bottom to the very top of the shape. So this is the very top of the shape, we agree? The height, usually you represent it with a dotted line because it's not an actual line there. It's just showing the length of the height. Okay, and then where would the height be on my right triangle? Yeah, the left. Because this is the highest point, and it represents the height. Here's what you need to note. The hypotenuse is never the base or the height. The hypotenuse is not going to be either of those lengths. So if you're given the hypotenuse, but you're missing a side, if you're given, let's say the hypotenuse was 7 and the height was 2, well, how can I find the base? Because I need the base to be plugged into the triangle. It's a right triangle, so you'd use the Pythagorean theorem. So keep that in mind. Okay, the hypotenuse is not helpful to you. So that's a triangle. The next one is a trapezoid. Okay, the trapezoid has the same formula, except for how many bases does a trapezoid have? 2 of them. Let's go ahead and write in the formula. We are also going to draw some trapezoids. So area equals 1/2 times the base 1 plus base 2 times the height. All right, so you're going to draw 2 parallel lines. They don't have to be the same length. So we're going to do something like that. We're drawing some trapezoids. We're also going to draw some vertical like this. A trapezoid has how many sides? It has 4. So go ahead and connect the lines that you just made as straight as possible. So your bases, base 1 and base 2, they're always the parallel sides. They will never intersect. So I did mine in yellow. So these are the bases. It doesn't matter which one you label 1 and 2, but I'm just going to, it's the first one I saw. Okay, so those are your bases. They're always parallel. They don't always have to be horizontal or vertical, but they are parallel to each other. Okay, and then the height. The height is what pushes the bases apart. Pushes bases apart. So in this first case, that would be up and down. And then in the second case, it'd be across. The height is what pushes the bases apart. This is pretty much the hardest one to be able to label. But what kind of sides are they, Javon? The 2 bases? How can I find them? Do you want to phone a friend? Who knows how to answer it? How do you find the bases? They're parallel to each other. That's it. Good. All right, and then a circle. What's the area formula for a circle?
Circumference formula.
That's the circumference formula. I want the area formula of a circle. Correct. Pi r squared. Is there a diameter formula for the area of a circle?
Yes.
No, there is not. It is pi r squared. That's it. That's the only option. If you were given the diameter, how would you find the radius to plug into the area formula? Divide by 2. Okay, the last one is a parallelogram. Parallelogram. And it is area equals base times height. Then if you want to draw a parallelogram, the base is still horizontal, but the height, see how these sides They don't represent the height. The height is from the very top of an object down to the very bottom. This would represent a height. Sorry that my line's crooked. Okay, so we're going to be using these formulas because the volume formula is area of the base times the height. So you're going to identify a shape. What shape is the base? Find the area of that base, and then multiply it times the height. Go ahead and go to page 2. Take your highlighter. This is a prism. What is the base for prism A? What shape is it? Triangle. Go ahead and highlight the 2 triangles. The volume formula for a prism is area of the base times the height of the prism. The height of the prism is what pushes apart my 2 bases. It's the distance from my 2 bases. So what in this picture, how far apart are my 2 bases? 2 centimeters. So guess what the height is? 2 centimeters. 2. Now we want to find the area of the base. What shape did we say the base was? A triangle. So what is the area formula for a triangle? 1/2 base times height. At this point, you are ignoring the rest of the shape, and you are specifically finding the area of a triangle. So I copied down the 3, the 4, and this is just a triangle. I drew it over here. What kind of triangle is it if the 2 triangles are congruent and parallel? It's a right triangle because the bottom is a right triangle. Okay, so from here, remember that the hypotenuse is not the base or the height. Are we given the hypotenuse? No. So then we're given the base and the height. It's 3 and 4. So we plug in 3 and 4. Now a lot of people get confused. Ms. Marshall, we just said the height was 2. Is the height of the triangle 2? Is the 2 attached to the triangle at all?
Yes.
Look at how we outline the triangle. Is 2 attached to it? No. It represents the height of the whole prism, which is different than the height of the triangle. Sometimes it helps people to just redraw the area that we're finding so you know what numbers you're working with. Now, it doesn't matter what order we multiply in because 1/2 times 3 times 4 is the same as 1/2 times 4 times 3. It doesn't matter. Would you like to do 3 times 4 first?
Yes.
Sounds good. I wrote a 3. I'm sorry. That's a 2. So 1/2 times 3 times 4 is 12. Half of 12 is 6. So what did we just find? The area of our triangle. So you take the area of the base, which is 6, and then we multiply it times the height of the whole prism. And the height was 2. So then the volume of all of this prism is 12. And it is centimeters cubed. All right, so we circle it. And then we do the same thing on the second. It's a little more complicated because it's a different picture. What shape is the base on B? It's a trapezoid. Go ahead and highlight the 2 trapezoids. Once you've highlighted the 2 trapezoids, it is very easy to find the height of the prism. So how far apart are the 2 trapezoids? 5 centimeters. Let me tell you a little hint. In letter A, we used 2, we used 3 and 4. Did we repeat any of the numbers? Did we repeat any of the side lengths? We did not. You will never repeat the side length. So once we've used 5, it does not represent anything else except for this 5. Does not represent anything else other than the side of the prism. Okay, we're going to find the area of the base. What shape is the base? Trapezoid, which is 1/2 times base 1 plus base 2 times the height. Again, sometimes it's really simpler if you redraw it a little bit. Copy over the 14, copy over the 3. Okay, what's the side length of the bottom of the trapezoid? This portion. It is 6. Good. 6 because the bottom was 6. Good, good. All right, so looking at our trapezoid, you want to ignore the rest of the shape. We're literally just finding the area of this trapezoid. Which of these are the two parallel bases? 14 and 6. Good. So we do 1/2 times my two bases, 14 and 6. And then times the height of the trapezoid. Again, we are only looking at the trapezoid. So how far apart are my two bases on my trapezoid? What were my two bases? 14 and 6. So how far apart are the two parallel sides? How far apart are they? There's 3. I just didn't hear you. I heard the number 10. Oh, okay. Not yet. The height is 3. And we get that from this 3 right here. Shows how far apart the bases are. Now we just math. 14 plus 6 is 20. And then times 3. It does not matter what order you multiply in. Personally, I find it easier to half an even number. I don't know. What's half of 20? 10. And then times 3 is 30. Any way you did it, you could do 20 times 3, which is 60. And then half of that is 30. Either way. So what do I do with this 30? Correct. Multiply it times 5. All right, so 30 times 5 is 150, and it is centimeters cubed. So our formula, volume equals area of the base times the height of the prism. So let's go ahead and highlight the bases. What shape are the bases? There are triangles. Remember that base does not mean it's on the bottom. Even though a rectangle is on the bottom, what does a rectangular prism look like? A box. Does this look like a box? It does not. Okay, so bases, there's 2 of them. It just means congruent and parallel, all that. So we can automatically find the height. The height is what pushes the bases apart. How far apart are the triangles here? They are 9 centimeters apart. So this is a case where height is not necessarily up and down, but it's what pushes my two triangles apart. So what makes it 3-dimensional instead of just a triangle. All right, so now we find the area of a triangle. What is the area formula for a triangle? 1/2 BH. Okay, what is the base in this triangle? 6, and then the height? 4. You can multiply 6 times 4 is 24. Half of 24 is 12. Sorry, I thought you said 24. All right, so 12 is the area of the base. So times the height, so times 9, it will be 108, and it is centimeters, right? Centimeters cubed. Good. So we have one more thing to do, and it's cylinders. So is a cylinder technically is it a polyhedron in the first place? No. So technically it is not a prism, but a prism has 2 congruent and parallel bases. Does that look like a cylinder has 2 congruent parallel bases? To me it does. They're 2 circles, right? They're the same, and they will never intersect. So technically it's not a prism, but it's close enough to one. It's got the same formula. So I'm going to teach you the way we just did it as one of the options, where we find the area of the base off to the side, and then we plug that number in. So I'll teach you that. It's method 1, same way we've been doing. Method 2, which will come in a little bit handy if you're given the volume and you have to find the radius. These are examples of cylinders, just in case you've never opened a can of soup. You could use this formula, or you could actually plug in the area formula for a circle, because the base shape is a circle. What is the area formula for a circle? Pi r squared. So instead of saying area of the base and going off to the side and doing pi r squared, you could plug in pi r squared. Does everyone see how that happened? This is the same as this. It's just specific to a circle or a cylinder. This way, I will show you both, one of each. Some people like going off to the side, finding the area, then plugging it in. Some people like just doing pi r squared times the height, but it just depends. This one, the second one, is easier when you're given the volume. So if I say the volume of a cylinder is 800 inches cubed, find the height or find the radius, this formula would be easier to use. Okay, so I'll show you both using these two examples. So this first one, we're going to do exactly what we've been doing. We're going to find the area of the base and multiply it times the height of the prism. So area of the base times height of the prism. The base are two circles, right? So what is the height of the prism? 6. Even though it's not a prism, it's close enough. The height is 6. We can go off to the side and find the area. If you are using a scientific calculator, you still need to use 3.14 because that's what the answer key will be in. Okay, you will need a calculator. What is the area formula for my circle? Pi r squared. And am I given the radius here? Yes, it's 9. All right, 9 squared is? 81. So you want pi times 81. 254.34? Okay. So that's the area of the base. Okay, we just plug it in for area of the base, and now we multiply it times the height. You both said very different answers. 2,289.06. No is right. It's 1,526.04, and it is feet cubed. I don't know what you typed in.
I just did times 9. Shit.
Okay, so go back. Yeah, but where did that number come from?
I put 9 instead of 6. My bad.
Oh yeah.
My bad.
Okay, so that's option 1. Option 2. Instead of writing this formula like this, we plug in the area of the base formula. What is the area of the base? What is the formula for it for a circle? Pi r squared. And then times the height of the prism. So times the height. So we literally plugged in the area formula for the area of the base, and then times the height. Area of the base times the height. So what is the radius of the circle? It is 4, yep. So pi times 4 squared times the height of the whole cylinder, which is 7. If you have a scientific calculator, I just ask that I see what you typed in. And make sure you're using 3.14. So 3.14 times, what is 4 squared? 16. So 3.14 times 16 times 7, and we get? 1,406?
1,406.72.
Do we agree? I don't remember that number. What number did you get? I remember that number. Let's go backwards. So 3.14 times 16 times 7. All right, I would like more than one confirming. Is it 300 something? Good, 351.68. And then it would be centimeters cubed. Okay, so at this point, you're going to get out a whiteboard and a marker. So, I need you to do this one at a time. So you answer the first part and then show me. Answer the second part and then show me. Answer the third part and then show me. Because the first says, what is the shape of the base? And what is the formula? Because it does not matter how good you are at math. If you get the base wrong and the formula wrong, you are super wrong. So to save you some time, tell me the shape of the base and then the formula, the area formula. Then part 2, you'll show me what do you think the area of the base is. And then you'll show me the volume. You are correct. What kind of prism is this? Rectangular. Here's the trick about rectangular prisms. All of the opposite sides are congruent and parallel. It does not matter which one you call the base. So here's what that looks like. Give me a second. So volume equals, I'm just going to put AOB, area of the base, times the height. Pick a base. Top, bottom, left, right, front, back. What do we think? Doesn't matter. There's no right or wrong answer. Shape. What two sides are the bases? What do we want to label as the base? The top and bottom? Okay. So area of the base would be length times width. Length times width is 4 times 2, which would be 8. And then times, can you see the blue? Kind of. Then times the height. What pushes apart the two bases that we just highlighted? No. What pushes apart the two bases? You said it. It's 1.5. So you'd multiply times 1.5. So essentially, which is 12, which is the answer. Essentially, just think about it. We did 4 times 2 times 1.5, right? 4 times 2 times 1.5. Let's pick a different pair of bases and see what that looks like. So not the top and the bottom. Pick 2 other bases. The sides. Sounds wonderful. So again, we do length times width. So what are the length and the widths of our boxes? 2 times 1.5. And then times the height. What is the distance between the two bases? It is 4. So then times 4. Can we just take a moment to look at this and this? Does it matter what order you multiply in? No. They're all the same thing. You're going to end up multiplying all of them together. Even if you pick the last set, what did we not pick? Front and back? You would still end up with 4 times 1.5 times 2, which is all the same. You will get 12 meters cubed any way you do it. So with a rectangular prism, do not overthink it. Just pick 2 bases and then go from there. Okay, let's try this next one. There's no steps. It's a cylinder. Go ahead and find the volume of our cylinder. Correct. So you'd still round to the hundredth. All right, so either way you did it, volume equals pi r squared times h, because this is the area of the base. Some of you did it off to the side. That is fine. What is the radius? 3 radius squared, and then times the height, which is 10.2. You should end up with, correct, 0.25 feet cubed. So because we're rounding pi to the hundredths, keep rounding to the hundredths. It's normal. Okay, let's go ahead and do the next one. There you go. Start with telling me the shape of the base and the area formula you would use for that base. The bases have to be congruent and parallel. Congruent means they're the same length. Let's just take a moment and look at them. Do the top and the bottom look like they are congruent? They are not the bases. Base is not a location. You're correct. Now solve. You're correct. Now solve. Stop you looking at other people's papers. There are only 3 locations. There's the top and the bottom, which we just said is not correct because they are not congruent, right? There are the sides. Are these 2 parallel? The ones I just highlighted. They're not parallel. Is your formula correct? So it has to be, listen, it has to be the front and the back. Look at them. Do they look like they're the same shape and size? Yes. So that shape is going to be the base. Go ahead and solve for that. I will say that this does, listen gentlemen, I think that this is much easier when you redraw the base because then you can see what numbers deal with the trapezoid that you're finding the area of and what numbers do not deal with the trapezoid you are finding the area of. So if you want to redraw it and fill in all the information. So you've got 1.2, 2.3, and 1.8. When you go to use the area formula for a trapezoid, these are the only numbers that are on the trapezoid. So which of these are the 2 bases? 1.2 and 2.3. And what is the height? What pushes apart these 2 bases? Nope. 2-dimensional. 2 has nothing to do with this trapezoid. It's 1.8. 1.8 is the distance from my 2 parallel bases. We're looking 2-dimensionally. We're not looking at the whole figure right now. We're looking at this. So 2 has nothing to do with this trapezoid. This 2 is something else. This 1.8 is the height of the trapezoid.
So you put that 2 for the volume then?
Correct. I will get there in a second. So we should get area equals is 3.15, right? You want to take the area of the base and multiply it times the height. The height is not always up and down. It is what pushes the 2 bases apart. So what is the distance between the 2 bases? 2. So times 2. And you get 6.3 Is it centimeters? Centimeters cubed. Notice how I did not repeat a number. I used 1.2, and I used 2.3, and I used 1.8, right? So check, I used 1.2, 1.8, 2.3, and then eventually I used 2. Did I repeat any of the side lengths? No. And it should be like this, okay, where you don't reuse a number because they all represent one thing. Okay, go ahead and do this one. Find the volume. You could just find the volume completely. You don't have to do partial steps. Just find the volume. So let's talk about volume. When you plug in pi r squared, are you given r squared? No. What are you given? The diameter. So if I know the diameter is 26.8, what is the radius? Half that, which is 13.4. So pi times 13.4 squared times the height, which is 9.8. You get a very large number, and it is 5,000 or 55,000? What is it?
5,500. Yeah.
You erased it already?
Yeah.
Someone type it in. Hurry up. We got one more question to do. What? Can you show me? Yeah, 25.42. 42, and it'd be centimeters cubed. We got one more to do together. So you are going to do the process. Number 1, tell me the shape of the base and the area formula for that base. Number 2, show me the area of the base. And then number 3, find the volume. Okay. Listen, we got 2 triangles. How do you find the area of a triangle? 1/2 base times height. This is a right triangle, so you want to make sure neither of these lengths that are given are the hypotenuse. Are either of them the hypotenuse? No, so we're doing good. 1/2 times 7 times 10, which is? 35. That is the area of the base. We then multiply it times what pushes the bases apart. How far apart are they? 5. So times 5, which you get 175? Inches cubed.